Is everyone thrilled and excited? Another beautiful day?
Yes.
Yes. And can class please end as quickly as possible so we can go outside and enjoy the weather? That would be nice.
Also,
Yeah. Okay. I would love to, but unfortunately, I need to get paid. So, all right. So today, I have a couple of things that I want to get done. First, I want to answer questions. A lot of people have turned in their homework already. Some people were having issues with it, and I want to spend a few moments answering any questions anybody has about the homework assignments. Some of those were tricky.
Imagine.
One of my questions is, can I have another screenshot? Because sometimes I can't read what the questions are.
Jacob's name.
You guys just want me to send it in the...
Yeah, it's hard to read.
I have a good copy.
Yeah, I might be able. Hold on 1 second. Let me see if I can pull this off.
I was genius brain yesterday.
Yeah, when I was doing the questions and I actually got an answer, I was like, oh my God.
Okay, I think it's successfully in the chat. Did that work for you? Whoever that was asking.
I got it.
You got it? Okay, good. Wonderful. Beautiful. Questions, issues, moans, whines, complaints.
I don't get question 21.
Yeah, take that, Emma. I get it.
It's easy. You start with 20 and then you add 1.
Can you do a...
Like all the consonants in the problem of 21.
Ah, yes, those. Yes. Okay, so the trick in these is to do your absolute best to get rid of the logs or turn it into some equation that allows you to not have logs in it, and then you'll just solve a system. All right, so how about we do...
Can you do 21E? That one just gave me issues.
E is a vowel.
I don't know why. What do you say?
E is a vowel.
21E, you're talking about solving for the homework, right? The problems?
We don't do vowels.
We don't do vowels. Consonants only.
I'm talking about the problem.
Yeah, I know. You didn't have to.
So,
it wasn't assigned.
So you're telling me I just did all the questions?
Wait, hold up. We were only supposed to do 20?
No. You were supposed to do 20 and 21, but you were only supposed to do the consonants.
I did everything.
No.
I got to use the bathroom and I came back and I just saw this like last class. I'm like, oh, I guess.
I did all of 20 and then got like most of 21.
I just did everything.
I did the consonants. That's what you said.
Yeah, well,
I didn't hear that part.
You only had A and E. So for those of you who did all of the problems, you just did 4 extras. But I will be more than happy to do E. Ta-da!
Yeah, for practice.
Did you also do C?
Yeah, I don't know why that one was so easy. It looks easy, but it just, I don't know.
Wait a second. You're saying E is difficult or E is easy?
It looks like it should be easy, but it just gave me challenges for some reason. Like I got all the other ones.
And my picture looks like crap. Hold on. Let me see if I can open it up. Because I printed it and it looks horrible. 1 second. Okay, now I can actually read the thing. All right, and then the other one was 7 to the, is that that's a Y, whoops. And that's a Y. Okay, now, can you read that or is it too faint? My pen too thin or is it, okay. We good? All right, fine, I'll use a marker. Okay, so the first thing I'm going to do is I'm going to say that this is equation 1 and this is equation 2 so that I can talk about them individually. And so equation 1, let's play around with it. I have 5x times 5 squared plus 7 to the y times 7 is equal to 3468. And I'm going to go ahead and, well, I'll deal with that later. And I also have equation 2, and I'm going to take equation 2, and I'm just going to go ahead and stuff it on in there. Okay, and so now I've got an equation with just x's in it. And so now I have 25 times 5 to the x plus 7 times 5 to the x minus, and that's 49 and 42, so 532 is equal to 3468. Take that over to the other side, factor out an x to the 5 to the x. And that gives me 25 plus 7 is equal to 3468 plus 532, which is 59. Oh, that's all the way up to 4,000. Yay. And so 5 to the x is 32. And 32, that's so this is, and I'm just going to go ahead and break this. Well, I can divide it out, but this is 5 to the 3rd times 2 to the 1, 2, 3, 4, 5, all over 32, which is 2 to the 5th, which is 5 to the 3rd. So x is equal to trace. And then you can just take that in and throw it in into anything you want, probably right up here. Okay, that's the easiest one. So 5 to the 3rd is 125. 125 minus 76 is, what am I doing? 120, that's 49. So that means 7 to the y is equal to 49. So y is equal to 2. And just so that, you know, because, and this was one of the things, like some of these problems gave you multiple answers. You know, you had like quadratics and whatnot when you were done with everything. And you, like, some people I noticed when they were giving their homework, they were saying x is this and this, or this or this, and y was this or this, but the x and the y were related to each other, like which x went with which y. So like if you wound up boiling it down, you had some crazy bunches of quadratics, and you got you know, x equals 2, and then you plug that in and you wound up with y equals 4. I'm making this up. Okay, this is just an example. And then the other answer was x equals 1/2, and then you stuck that in and you got y equals 50, whatever. So some people were saying that x was an element. I love that you were using the right notation. You know, you were saying this, and y is an element of 4 and 50. Well, the thing of it is that y is only 4 when x is 2. You know, it's not like you've got all of the different choices in here. It's not like 2 and 50 are an option, and 1/2 and 4 are an option. In fact, what your answer is a set of ordered pairs. It would be 2, 4, and 1/2, 50. Because they're actually solutions to a system of equations, and a system of equations can be graphed to find a coordinate pair. So in fact, I mean, if you were going to be really, really technical, you would say this. Or you could just say, and I'll be happy to. I mean, that's just fine. That's what it is. But you just want to make sure that you're associating the right value with the right answer as a coordinate pair, because they are a pair of numbers that go together. Okay. Anyway, that's just me being picky, but it's important. Okay. Other questions, issues, moans, whines, complaints?
Question 21B.
Love that one. I love
that one. I got 2 answers for them. I'm just really worried about what X is because it took me a while to get it.
X is a letter. Okay. My answer is X is the square root of 3 and Y is 9. And I really, really enjoyed this one. You know why? Because it could be solved in so many different ways. And the other thing that was really cool was that I screwed up and I had to redo it. And I really enjoy that because I love finding my errors. And I love, you know, the fact that I found a problem that stumped me for a second. And it was like, oh, snap. What did I do? Crap. Okay. Anyway. Okay, by the way, I want to throw one thing at you because I realize that some of you guys are reaching out into like into the YouTube universe. And you're saying you're coming up with things that look like, for example, like this log of 27. Wait. Well, let me pick one that actually really popped up because people were like jumping through it. And I was like, snap, that's not really too nice if you're not telling me how you did it. All right, wait, we can find a really good answer. They're the hard ones. Okay, so let's simple. Let me give you this. Log base 9 of 4. Some people were just going ahead and jumping around and saying, oh, well, I know what that is. That's log base 3 of 2. And I'm like, okay, how in the world did you so easily and comfortably do that without showing me any reason or rationale? Okay, so if you're going to create your own log rule, you should at least once explain what it is. It is true that these are equal, but you should at least walk through the process of how you did it. Otherwise, I'm like, oh, great. So somebody just, you know, is looking up the answers or whatever, is using some computer program. You use exchange of base. This is log base 3 of 4 all over log base 3 of 9, which is log base 3 of 4 all over dose. And then that becomes 1/2 log base 3 of 4, which is log base 3 of the square root of 4, which is log base 3 of 2. So these two are equal, but it is not intuitive that they are equal. Okay, and if it's not intuitive that they're equal, then you should explain it. Otherwise, you're basically cribbing it off of somewhere else. Okay.
What if with 9 I put it as 3 squared and then 4 with 2 squared and just canceled out the squares?
Ooh.
Does that not work like on all of them?
I don't really think that that is something that can be done. For example, I mean, I'd have to break that and prove that to myself. But I don't necessarily believe that that flies. Take a look at how about this? Of say, let's do 4. Okay, let's just see what happens. So this is log base 3 of -2, and 4, which is 2 squared. So let's just leave it as 2 squared. Okay, now what I think you want to be able to do is you want to be able to tell me that that is log base 3 of 1/2. Is that what you're saying? Because the 2's would cancel and then I could put that negative, I mean, like divide them both by -2. And then it would become this. I don't know if that flies because if I use the change of base formula on the original, let's just use it on the original. Log base 3 of 4 all over log base 3 of 1/9 is log base 3 of 4 all over, well, and this is to the -2, so this just becomes -2. And so -1/2 log base 3 of 2 squared, bring that down, and it does become actually log base 3 of 1/2. I just, it makes me nervous because that's not really, I mean, think about it, like, think about what you're saying is this. I just, it doesn't make me feel good. A to the B to the C is equal to log base A of C to the 1 over B, which is 1 over B log base A of C. That's the question mark. Is that true for all values of A, B, and C? So let's see if we can do it. Let's prove it. Let's say whatever the heck that is, log base A to the B of C is equal to something. Let's call it X. So that says that A to the B to the X is equal to C. So now, and what we're going to try and see is, does log base A of C equal BX? Because that's what this is saying. We're going to make this equal to X. And so if that's true, then X would be equal to this, which means BX is equal to that. So according to that, A to the BX is equal to C, which flies. And that would only fly if A and C were positive, because if they're negative, then they're weird. But you can't have a negative base or a negative log component. So I'm okay with it. Just be gentle with it. Treat it with kid gloves. It should be okay. Cool. Other questions, issues, moans, whines, complaints?
21C.
You see, I don't know how you guys do all of your homework on like Post-it notes. I'm serious. Like I look at your work and it's like, you know, one photograph gives me like the whole page. I'm like, this is mine, guys. I mean, like 1 page. Okay, there's 2 pages, and then just 3 pages, and 4 pages, and 5 pages, and 6 pages, and 7 pages, and 8 pages, and then that's it. Yeah, I don't know what you guys. I mean, you guys are just like, I don't know. I'm gonna Wolfram Alpha it. All right, what did you need? D or C? You wanted C. Okay, that's a fun one. Y log base 2 of 8 is X. I love this kind of problem. This is the kind of thing that, you know, peels the paint off the walls. A to the Y, which is equal to 8192. So this is pretty straightforward. This is 3y is equal to X. And then going on ahead, you can do this in different ways, but I'm just going to go ahead and substitute. This is 2 to the 3y plus, and take a look, 2 to the 30y is equal to 8192. And let me guess, you probably got somewhere close to that.
I thought that said 8 to the first. That's not a Y. That's where I was getting.
Yeah, I did the same thing as Emma. I thought that was a 1.
Well, look in the screenshot.
I had to squint on my screen with my glasses on and find it. I mean, I got it, but it was like, it was hard.
That still looks like a 1 to me. Like I'm squinting and it looks like a 1.
Why would it be 8 to the first?
The Y. It's just blurry. You can see 2 other dots besides that quote unquote 1.
Like,
and
why
then if you
wouldn't it
connect
be
the
8 to
dots,
the
it's
first?
just a Y.
Okay, because we're not in like pre-algebra. And besides, you saw it here.
Oh, I didn't get past B.
I really enjoyed C, 20C. That was fun. Anyway, moving on. Okay. And the fun part here is, what the heck do you do with this? And, you know, no, you cannot, you know, turn this. This is 2 to the 13th. And no, you cannot say that 3y plus 3y equals 13. That does not work, people. What are those?
Like terms.
Yes, they are.
So is it 2? Okay.
Wow. You don't know how many times I've asked a question like that and kids are like, what do I do here? Like combine like terms. And they're like, dude, you suck. Why would you do that to me? And the rest I think you can do. Other questions, issues, moans, whines, complaints.
So I actually got to that point on 21C. I just want to, from what I'm looking at, I just want to see the steps that I take in the future will be right. So when you divide that 2, will that become 2 to the 12th
Correct.
on the other side?
Yes.
Okay.
Yes. 2 ways you can do it. You can either divide both sides by 2 and get 2 to the 3y is equal to 2 to the 12th, or you can turn it into 2 to the 3y plus 1 is equal to 2 to the 13th. And in either case, you'll come up with the same thing.
It's funny. This homework, I actually had fun on it.
It is fun. They're good little puzzles. I love this book.
Well, it's because the answers were all nice whole numbers. It was just, everything just went into place.
Yeah, everything came out. I mean, there's 1 square root in here, but most of everything was an integer, a couple of rationals, but yeah, it wasn't too bad. Yeah, most everything came out nice and pretty. Yeah, this is a really good book. They don't use it. No one makes it anymore. It's ancient and it was only published for 1 year, and I happened to steal a copy. Beat up an old lady for it. All right. So, okay. Other questions, issues, moans, whines, or complaints about the assignment or anything else? Okay. So what I'm going to do now, I want to show you a nice piece of software, okay, that I use literally every day. Okay. Okay, so give me a hot second, and 1 second. Where the heck are you? HL1. All right. So I'm going to show you the Canvas page for your class. Okay, so there's no big surprise there, but okay, so this is your Canvas class. Now I've added these 2 links down here in the bottom left. Okay. These are the web versions of probably the coolest, or one of the 2 coolest visual programs for solving of math problems that I use. Okay. We're going to get into GeoGebra 3D. GeoGebra is a portmanteau of geometry and algebra. You know that word, portmanteau? Probably not. A portmanteau is something that is a mix between of 2 words. Blah. What's a good example of gosh, now I can't think of a single one.
When you put 2 names of like 2 people together.
Let me see if I can just find a simple example of a port, for crying out loud. Smog, there's a good one. Smoke and fog, right? Motel is motor and hotel. Yeah, all right. But yeah, where, brunch, breakfast, and lunch, where you take 2 words and mush them together. Okay, anyway. So I've added these 2 links down here, and I'm just going to show you Geogebra Classic. Now, the cool thing about GeoGebra, first of all, it makes Desmos look absolutely pathetic. Desmos sucks in comparison to GeoGebra. I actually had to write an essay for my master's program on computer technology, and it was actually a whole course. And I had to do a comparison of GeoGebra and Desmos. And I ripped Desmos a new one, and it was just really, really rough. And it was like I had to list all the things that GeoGebra could do and Desmos couldn't, and the other way around. And so after like 4 pages, I had to say the good things about Desmos, and the only thing I could put was it's got pretty colors. And then Oh, wait. Desmos has those too. Sorry, GeoGebra has those too. So, I mean, there's really nothing that Desmos has that GeoGebra doesn't. For example, it can graph almost anything. First of all, one thing that it can do that other things can't do is it can actually graph a vertical line. It can do things like it can graph y to the x plus x to the y equals 1. If I can see it, I'm sure. Well, actually, this is the wonderful thing. I hate the app. I use the computer program that actually is like the downloadable one. Huh, I wonder why it wouldn't even give me an answer. Okay, let's try it. Let's try it on the actual program itself. You can download it, and it's free. You can also get it on your phone, and it will graph anything you want. And actually, I'm just going to do that one that I had before. Y to the x plus x to the y is equal to 1. Wait. Maybe it doesn't have an answer. Okay, like it's going to graph stuff that you normally would never be able to see. And then we can put in a slider and see what happens. See, it doesn't like some values, but it likes others. Here, hold on. Let's just play. Okay, let's just play. Let me show you some fun stuff that this can do. It can graph, like I said, anything. But let me see. 2020 type. Let's see what's going on in here. These are some fun ones. This is one that we're going to do next year. This is the solution to a differential equation, which we're going to learn how to do later. And I'm just going to go ahead and turn that on. That's some fun stuff. Let's go ahead and play with that fella. And I'm going to turn you off. This is another solution to another kind of problem. And where is my implicit curve? Okay. Nope. These are just some of the really cool pictures that you can do. That's the one. Nope, not that one. Nope, not that one. That one. And what's happening is you're going to be able to see where the planes intersect and other things like that. It can do almost anything you ever really wanted it, any program, graphing program to do. It can also do like geometry stuff, you know, I mean, find how about a perpendicular bisector of that. And then we'll do that again. This is what's called the Voronoi diagram. And let's put in another one just for giggles. You get to play around with things and then see what happens. So yeah, there's lots of really fun stuff that you can do. What's very anticlimactic? Oh, Herminio is just not impressed. Oh, I'm so sorry. Herminio, you're just, you know, you're tough to please.
What happened?
Yeah, uh-huh. Okay.
I'm very impressed.
I'm sure you are.
Trust me, you can hear it in my voice.
Yeah, I know. It's thrilling stuff. But hold on, let's see if I can put this in here. It can do all sorts of crazy stuff that you normally would not be able to do with any graphing program. It'll also do what is called a locus of points. Okay, so nonetheless, you can do geometry. You can also graph anything you like. How about y is equal to, oh, here's something you can't graph on a calculator. Y squared is equal to x. You can graph non-functions. You can even graph, you do parametric. Now, I don't do parametric too often, but it can do all sorts of crazy stuff. I do believe that it can do weird stuff. Moving on. And you can do all sorts of crazy things that you want to play around with it. And so on. Okay, but I highly recommend you get yourself slightly familiar with it, play around with it, download the program if you like, and screw around, because there's some really good things that we'll be able to do, despite what Herminio might be crying about. Anyway, it also is a way to solve problems as well. Yes, you can make a 362-agon. Yes, absolutely. It looks like a circle. But I mean, I don't know. I've just definitely done some really fun things with it over the years, and you can do lots of really fun things. Let's see if I can just find. Yeah. All right, this one's fun. And then I'll just show you two more. this is what is called a parallelopiped. Yeah, I know. I didn't make that up. That's a real thing. Okay. And a parallelopiped is a three-dimensional analog of a parallelogram. Fun. And you get to play around with it, and you know, it's easy to make. And then another one that was really kind of fun. Oh, I'm going to teach you how to get out of a traffic ticket using calculus. That's fun. There it is. Yeah, that's what's called a cardioid. I don't need two of them. And this was actually a solution to a problem. We had to find the tangents, or the point of intersection of the tangents of these 2 points. This was, this is actually what we're going to be doing today. I don't have to remake it. Yay. Hopefully, eventually. Yes, there we go. And we learn about the graphing of curves and what they are and what they do. And so we have all this fun stuff to play with. And it's really nice because it allows you to visualize what's going on. There's it. And we're going to be talking about the relationship between the log and the exponential and how they are related. So yeah, lots of really fun things that you can do. Okay. So what I wanted to do today actually is go into a few word problems related to exponential growth and decay. Okay, so how do we deal with radioactive growth and decay? All right, before we can talk about this, we're going to go back to the very, very, very basic idea of rate, interest, simple and compound interest. And then finally, we have continuous growth. We'll get to that last. So this is our newest thing we're going to be playing around with, because these talk about they go back to both topics that we've covered so far. They talk about sequences and series, but they also talk about logarithms and exponentials. So for example, let's talk about simple interest. Simple interest sucks. Simple interest, if you're getting simple interest, then you should choose a new bank. Simple interest is one that compounds yearly, compounds once per year. Okay, and that sucks because that means for 364 days, somebody else is using your money. And then they just give you this little token at the end of the year. It's kind of a waste. So let's talk about it. Let's just say, for example, the formula for it, by the way, is amount final is equal to the amount initial, 1 plus the rate, and then t, which is time. Now, let's look at some of these variables really quickly so that we can talk about them. Okay, amount final, initial. In your economics classes, this is often called the principal. It's the amount of money that you started with, and nothing has happened to it yet. It's like the amount of money that you deposit. We've got my rate, and this rate is represented as a percentage, or not as a percentage, but as a decimal, not as a percentage. Excuse me. And then time. All right. Now, a similar question or formula comes from just the interest. The amount initial, the rate times time. Or usually the rate is, the amount of time is considered 1. But here, this is your interest only. And the reason, if you look carefully, the difference, it's 1 plus r to the t. So the deal of it is that with the 1 involved, we're going to keep the amount of the principal. And then we're just going to add the interest on top of it. Okay. Now, usually this is considered 1. Usually 1. If it's not 1, then you really want to use this formula. And the reason why is because exponentiation does not distribute over addition. So this, if t was, say, 2, this is not 1 plus r squared. Okay. So usually we don't even see this in there. Usually it's just the rate times the amount initial. It gives you your interest. All right, now let's keep going. All right, now like I said, simple interest sucks because nothing really good comes out of it. I mean, like I said, somebody else is using your money. But what's nicer and more fun is compounded interest. Okay, now here's the way this works. In compounded interest, we're going to take an example. Let's just say a bank offers an account at, and just to make the numbers a little bit more interesting, 10% interest. By the way, if you ever were to find some bank that offered an account at 10% interest, borrow every penny that you can, steal the rest, and put it in there. 10% is great. Yeah, most banks only give you 2, and if you're lucky, 2.5. But yeah, 10%, that's great. Okay, now here's the deal. If we invest $1,000 for 1 year, how much do you have? If it is compounded, and we're going to talk about this in a second, once, twice, 3 times, and 12 times per year. Okay, so if we're talking about compounding once, that means we're dealing with simple interest. So that one is not so bad. Amount final is equal to 1,000 times 1 plus what?
0.1.
Yes. And we do it for 1 year. So this is 1,000 times 1.1, which is 1100. So you made $100. Yay. Okay.
Yay.
Yeah, really. By the way,
Still a lot of money.
well, it is for, a single year. That's not so bad. 10% growth is pretty good. But let's be honest, the only reason why they're giving you 10% is because they're making 15 off of it. And they're keeping the difference. They're using your money. Okay. Remember, nothing in this world is free, especially money. Okay. Now let's start talking about what happens if we compound. Now, compounding means that that we break up the interval into different pieces. So compounding, we are breaking up the interval and rate into smaller chunks. So what this means is that if I compound twice, what that means is now instead of my rate being 10%, my rate is half of that. I'm going to go to a generalized formula in a minute. Now, this is going to happen each 6 months, you see. So in 6 months, you're going to get some interest. And then 6 months later, you're going to get some interest. See what I mean? So this process occurs 2 times in the span of a single year. Okay? So let's compute what that is. So, and that is 1,000 times 10, 1, 1, 2, 5, 4 wait, 11025. And then I have 4 decimal points. So that is 1102.5. So you made a little bit extra scrap, made a little bit of money off of that, okay? Because I compounded more than once per year. Okay, so it was a good thing for me to compound more than once. And the reason why it happened is because, let's think about this for a second. At time 0, at time 0, you have $1,000 in the bank. In 6 months, so half of a year later, we gave you one of these 5%. Okay. And that would have been, 1,000 times 1.05. Okay. So you would have made 1,050. That's how much you would have in the bank at the 6 months mark. Does that make sense? We good? Now, 6 months go by and we have not the $1,000 in the bank, but we have 1,050. So what's happening is that we're making interest on the interest. You see, we got 50 bucks in interest, and then that gets to add more money into the pot. So now it's 1,050 times 1.05, and that gives me this guy, which is 1102. This $2.50 comes from the interest on the interest. Do we feel okay about this? Okay. Now, let's say we compounded 3 times per year. So now it's 1,000. This is amount final. This is 3 times. This is now 1, and here's where we're going to start getting into a generalized formula. I have my rate divided by the number of times I'm going to compound, which is 3. So I'm not, you see, 10% is the whole year. but, you know, every 4 months, which is a third of a year, I'm going to get a third of 10%. I'm going to be getting 3.33%. And that's going to happen 3 times in the span of a single year. Okay. 3 times 1 year. Okay. So now plugging in everything that we got 1,000, 1 plus 0.1 all over 3 to the third. And at this point, you're starting to really probably need a calculator. So, and this is good because you guys are addicted to them. And so, you know, that's just going to be all fun for you. Yeah, you can feel the love in that statement. Yeah. Okay. So I've made $1,103.37. A little better, but not thrilling and exciting. So let's just say, what the heck, man, we're going to jump and do this. We're going to do this 12 times a year. So and we're going to compute what that guy is. Yay, you've made $4.71. Even Herminio is excited about that. Yeah. Yeah. So it's kind of anticlimactic. It does give you a little bit more, but it doesn't give you an enormous amount more. Okay. But it's enough to say I would prefer to have compounded interest versus simple interest. Okay. Now, let's take this a little bit further. Let's say you found the bank of your dreams. You have $1,000, and this banker is really dumb. He's going to give you 100% interest. So what the heck does that mean? What's my rate?
1.
Right. Now,
Get a whole $1,000.
yeah, so at the end of the year, he's going to give me another grand. I like this banker. I don't know. I think his name was Bernie Madoff. I'm not sure. But you guys don't know who Bernie Madoff was, do you? You guys were in middle school when Bernie Madoff got busted. Okay. Yeah, he was a con artist. He stole millions and millions of dollars. And got like 10 years for it. It was ridiculous. Yeah. So if you ever want to become a criminal, just be a white collar criminal. And here's the deal. I'm going to see how this behaves. I'm going to compound it once. I'm going to compound it twice. And I'm going to compound it 12 times. Now, let's see what happens. So I've got 1,000. 1 plus 1 to the 1. You're going to get 2 grand. Ooh, that was exciting. Let's compound it twice. And so this is 3 halves 9 over 4. So 250 times 9 gives me times 9. So that's $2,250. Pretty good, right? Now, let's compound it 12 times. So what's happened here is that, you know, we've gotten a little bit better, and it's a substantial amount of money. I mean, don't shake your fist at $250. And so, you know, we got this very stupid banker who's decided to be really, really generous. And now it's $2,600.13 and $2,600.13 and 4 cents. Pretty cool. Okay. So now he turns to you and he says, you know what? I like you so much. I'm going to go ahead and compound this thing every week. So now it's going to be 52 times per year. And you're like, wow, that was really kind of really nice. I mean, instead of once a month, it's now happening 4 times a month. But it only got me, $80. So
$80? That's a lot.
$80 is $80, honestly.
$80 is $80, but you're thinking to yourself, like, at some point, this isn't really doing a hell of a lot for me.
Man, you know how many Big Macs I can get with that?
That's a whole month of food right there.
Oh, absolutely. But remember, we're shopping for banks, man. So now you're like, you play hard to get with the banker, and you say, I'm not impressed. And he's like, fine, I'll compound it every day. Let's see. Fine, dude. Sure. Got you $26 more or $28 more. So what?
Hey, look at that.
Yeah, really? 22 bucks. That's all you're getting. It's $22.
Well, still 100 more than.
Well, don't get me wrong, but I want you to see where we're going with this. Like, the first iteration gave me a pretty substantial increase. You went from 2,000 to 2,250. That's a big jump. And then doing it 6 times more, or 6 times as often, brought it up, not too bad, $360, but it was 6 times as often, right? And then going up here didn't give me much. And then going all the way to 365, really, do you see that we're kind of like slowing down my growth, right? It's approaching a value. And now what happens is, and we've done this with our calculators, if we were, and I'm just, you can, if this were to keep on going, okay, and basically what we're talking about is this, the amount initial 1 plus 1 over n to the n. Now you take this, okay, and we can for a moment ignore that because we don't care, it's just a multiplier. As n gets bigger and bigger and bigger and bigger and bigger, we don't really see much growth. So let's just see what GeoGebra, even if it's not very exciting, Herminio, what it will do to help us. So let's say because we're not really interested in negative time. As you can see, the amount of money that you approach as X gets bigger and bigger and bigger is approaching, oh wait, you don't even see it. Sorry. There you go, now you can. That's the graph. What do you call this kind of behavior? You learned it last year. Saw this kind of graph before? Where as you get further and further and further away, it approaches a value. What do you call that?
Exponential.
Asymptote.
Yeah, it's an asymptote. Okay. If we think about our end behavior, as X approaches infinity, Y approaches some value. Okay. And as we go further and further and further away, you know, you can plug in and see what happens. You know, F of 1,000 or 10,000. Where are you? I need the right brackets, don't I? Oh, you see, it's too big for it to figure it out right now. I'll make it a little smaller. Ooh, it really doesn't like me. It's approaching this 2.7 value. And in fact, let me see if I can show it to you in a slightly different way. Oh, wait. It needs to do it in certain intervals. That'll do it. It can handle 10,000 computations. Takes a second. My school computer was built for this. My home computer wasn't. See if I can do it in a little faster way. There we go. So that's what's happening. So there the values are at 1,000. Here it is at one time per year, which is 2, which we saw. And then here it is at 1,000 iterations. You know, it's compounding 1,000 times a year. And here it's compounding 2,000 times a year, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000 times per year. Okay. Now, as you can tell, I'm approaching a value because my decimals don't really change too much. That value is a very specific one.
Is that E?
And as you can tell, as we keep going out further and further, less and less is changing, even to the point where I'll do it 1,000,000 times. And the little engine that couldn't. This can do it. Come on, buddy. You suck. Okay. There they are. There it is. And I'm going to put it out to 10 decimal places. So as you can see, compounding it 100,000 times gets me within a very, very small difference between that and the numeric value of E. This is what E is all about. E is the maximum growth possible. You can't grow faster than it. If you're doubling your value over and over and over and over and over again, the best and fastest that you will ever be is growing at a rate of 2.718281828. And no, it does not repeat. Okay. It looks like it repeats 18281828, and then all hell breaks loose. It's an irrational number. Okay. Now, when that happens, so as n gets bigger and bigger and bigger, you wind up with this. Now, this is for 1 year. So let's go back to our generalized compounded interest formula. Amount final is amount initial, 1 plus r over n, and this is n times time. And so the reason why we have this t here is if we're doing it for multiple years. So let's think, if I was to be compounding every month, n would be 12, and if I did it for 1 year, then that would be like we saw before. But if I'm doing it for 2 years, this will be 12 times 2, and it would compound 24 times. Does that make sense? Now, if this goes off to, as n gets bigger and bigger and bigger and bigger and bigger, we wind up with what is called continuous growth. And you get that. Now, this is when your rate is 100%, right? Now, if we were talking about the rate, this r not being 1, so this is when the rate is 1, okay? If the rate is some other value, but it is happening all the time, we turn this into a slightly different formula. And so we have continuous growth with rate equal 1. I should just put that in there. With rate equaling some constant k. And we get this. Now this k is the rate, but it's often called a constant of proportionality, or it's your rate constant. Okay, and in this problem, r was 1, so k was 1. Okay, and that means that it's growing, it's doubling itself. Okay, so let's talk about what that means. First of all, has everyone got this copied? Are we all good to go? First of all, have you guys seen all this crap before?
I remember like there's a PRTE square or like something like that. There's just a formula.
Yeah, well, the constants are probably labeled differently.
Yeah, it's just different labels, same thing.
Right, because they're probably talking more economics than we are about, say, something else. What about the rest of y'all? You guys are really, I gotta mute all of you guys. You guys don't stop talking so much. Seriously. Wow. Okay. Wait a minute. Did I just totally blow over the timeline? Yeah, I just totally screwed up the clock. So it's 2:40. Class is over.
That's fine. Keep going. It's all good.
I know, right? I mean, like, I could keep going for a couple more hours, but you guys probably want to go out and enjoy that sunshine.
No. We can stay.
Oh yeah, sure. Yeah, right. Yeah. Okay. So here's what I will do. I will throw at you. I'll just send it out in an email. Just a handful of problems to do. Not too excited. I know it was interesting. Okay, 10 minutes. 10 minutes. So let's just quickly do this really fast. So if I have like this, so if I have amount initial e to the kt. Now, here's the deal. If k is between 1 and 0, okay.
Mr. Ronco,
Speak to me.
is it okay if I go? Because I have an oral at 2:45.
We all gotta go. It's after class. Get out of here. All y'all go.
Thank you.
Thank you. Bye.
Thank you.
Thank you.
See y'all.
Thank you. Have a good weekend.
Merry Christmas. Happy New Year.
Oh, just to clarify on the logarithmic practice problems, is there a specific date you'd like them by? I would assume at maximum Monday, but like today.
Yeah, whenever you get to them. It's
Okay.
fine. I'll live.
I'd
like to have all my grades. I'd like to finish doing all of my grades because right now you guys don't have any of your grades in the grade book.
Mm-hmm.
But I want to get all the grade book stuff straightened out by the end of the day on Monday. So if you can get that to me, that would be nice.
Got it. And the previously mentioned 10 other questions for interest.
Oh, the ones for today?
Yeah.
Yeah, don't worry about that. I mean, I'm just going to give you some things to chew on. It's not going to be too exciting. I mean,
but it's still graded, right?
Yeah, I mean, I'm just basically it's completion. I mean, I'll look it over and I'll be like, dude, you don't know what you're doing, or I'll be like, he's got it, whatever. And
I just want to just have everything just planned out.
I feel you. You're good. No, but yeah, if you worry about the log problems, get them out of the way. If you, I'm not gonna look into this homework assignment that I'm gonna give you today by Monday. That's just too much, because not everyone's gonna be done with it by Monday. So that would happen in the next class, which would be next Tuesday.
Got it.
Okay.
Well, thank you.
Have a wonderful day. Petit, what's up? I have no idea what the hell you're saying. That's what happens when you mute and try and talk. Hold on. Bible, what's going on? Are you there? Guys, I can't hear you. You're muted. Hi. I don't know what you're saying. Unmute. Hold your space bar down, dude. Hold it down.
Okay, I'm sorry, but my Zoom is frozen and I'm unable to leave the meeting.
Oh, well, then I will be happy to kick you out.
Okay. Thank you, Mr. Ronco. Have a good weekend. I'm sorry
No problem. I was like, what is this finger gesture you're doing to me? I don't know what you're doing. Let me see if I can kick you out. All right. Bye-bye. Pavel, what's going on, man? Are you there? Okie dokie.